Welcome to the demo video of the Challenge Response Authentication, developed as part of Work Package 5. This demonstration addresses the challenge where an impersonating attacker sends messages on behalf of a legitimate device. To counter this, our solution is to exploit reconfigurable intelligent surfaces to obtain an authentication protocol at the physical layer, which we will showcase in this demo. This solution will be implemented in the 6G RAN of robust 6G architecture and validated in Use Case 1, Scenario 2. Here is a concrete example where we use RIS Obtain an authentication mechanism. Agent Bob wants to verify if the received message comes from Alice or Eve with challenge response authentication that includes 4 steps. In the first preliminary step, Bob registers the power of the received signal when Alice is transmitting and the configuration of RIS, for example, the direction or reflection of the signal. Then Bob sets a random configuration of race in Step 2. A transmission occurs in Step 3 from either Alice or Eve, and in Step 4, Bob verifies if the power of the received signal matches the power registered in the first step. If Eve is transmitting from a different position with respect to Alice, the received power will be different than in Step 1, allowing Bob to detect the attack. A first experiment was performed using a relay instead of RIS, which actively retransmits the signal in a configurable direction. Several transmitter positions were considered in an indoor scenario. Here we show the obtained experimental results, where each plot shows the power received with the transmitter in 2 different positions corresponding to Alice and Eve. The x-axis indicates the direction of the signal selected by the transmitter, while the y-axis identifies the current configuration of the relay. We notice that the 2 plots change dependently of the position of the transmitter, which allows the received to distinguish the 2 devices, providing another technique for authentication. We are now working to perform the same experiment with RIS instead of the relay. The comparison of the results obtained with the 2 technologies will be of interest, and we expect that RIS technology will provide effective support for new authentication mechanisms. This solution will be integrated within Use Case 1 and Scenario 2, and will contribute to Objective 5 by providing a novel authentication protocol with low latency and low footprint.